Okay, so to go a little bit further, we'll have a look at the first question from 7b, and it asks us to look at this x on a, or arc cosine x on a, which is part of what we need to build up to. So to build it up, we'll have a look at this question. That'll help with it. And then you can have a go at question 2, which uses the tan, similar sort of process. So this question asks us to differentiate the arc cosine of x over a so that we can show that the integral of this stuff is equal to this. Now, once again, contrived type question to show something works, but it does involve a bit of thinking. We're going to practice some of the things that we looked at in the previous video. Okay, so if we know that y is equal to arc cosine x over a, then the first step we did before was to say, well, let's get the inverse of this, so we get back to a function, a cosine function that we can find the derivative of easily using our rules. So if we're swapping our x and our y, we need to bring the a with the x, it's sort of attached. So therefore, we can say that x over a is equal to the cosine, because that's the inverse of the arc cosine, of y. Okay, looks a little bit better, and we'll do one more step and say it's x equals a lots of cosine y. Okay, and we can find the derivative of that quite easily, remembering from the previous video that we're now finding dx dy, okay, the derivative of x with respect to y. Okay, it's the opposite to what we've always been doing all this year, so just really concentrate on what you're doing there. What we're going to then say is, okay, well, if I want the derivative of a being just a number, a constant, so it doesn't affect the derivative, we just can leave it out the front, and the derivative of cosine is the negative sign. So we're going to have effectively a lots of the negative sign of y. Okay, that's what dx dy equals. Just like in the previous video, we're going to use an identity here. The same identity, but using the sine version of it to turn it back into cosine. The reason we want to turn it back into cosine is that we have values for x in terms of cosine. So I'll be able to put it back in again. So it's the same identity effectively. We'll leave that a out the front, but we're going to times that or change that to be the negative square root. Okay, so the negative is still just this negative here. Okay, all we're changing is the sign of y. Okay, the square root, because the identity we use is saying the sine squared of y is equal to 1 take cosine squared y. Okay, so we're just changing its form using that identity. The reason being is that we then have our cosine squared y. All right, we can use that cosine y and convert it back to x's. Okay, in this case, it's going to be x divided by a. So we've got a lots of minus the square root of 1 take x over a squared. Okay, and that's it. Okay, last step, remembering that this is in dx dy. Okay, we want the reciprocal, we're going to flip that over to be dy dx. Okay, so therefore dy dx, okay, because what we're really trying to find is the derivative of this function here, which says y equals arc cosine. Okay, so we want to find the derivative of y with respect to x. That's our aim. So that becomes the 1 on a. Okay, so we need to do the reciprocal of the a part, and we're going to multiply that by 1 on the negative of this stuff here. X over A squared. Okay, now that's, that looks a little bit messy at the moment, and we do have the A available. Okay, the one on A available to sort of try and multiply through and make this a little bit neater. Okay, so what we're going to do, because it's asking us to find the integral of this stuff, you can see that looks a bit tidier than what that does. Okay, so let's just go through the process of tidying that up now. Let's multiply 1. We're going to leave the negative that's here. Well, that can just come out the front of it all. So let's put the negative out the front first. Okay, the 1's across the top, well, that's just going to stay as 1. Okay, the last part is that the A needs to multiply in here. But we got to be really careful because there is a square root symbol here. We can't just go and multiply the A into that directly. We have to do something. And the trick for this one would be to say, let's make that A squared under a square root. So that's still A, but I've changed its form so that I can put it under a square root as well. So I'll write this line. Now I can do something because our third rules tell us that we can put all of that A squared, and multiply it by 1 take x take A all squared. We can put that under all one square root, one square root symbol. Now we can multiply the A squared through. Okay. Just a word of caution, I was looking and checking how the answers in the work solutions did it. They don't show this step. They do a massive jump. And I don't particularly like that because it doesn't make logical sense. So if we tidy this up now, we've got 1 over the A squared, so we've got the square root, don't put the negative, just becomes A squared. Okay, and then take, well, x over A all squared becomes x squared over A squared. So the A squared is going to multiply to the top of that fraction, divide by the A squared on the bottom. We're going to be left with just x squared. Okay, so what we've done is actually show, remember this is dy dx. What we've done is we've shown that the derivative of this thing must come out to be this thing. Okay, we've shown that. We've gone through the process of going through it. It's not an easy one. You've got to do a bit of work, but we've shown it. Why would we want to do that? Because if that's the derivative, then if we find, let's go over here, so if we find the integral of negative 1 over square root of A squared take x squared dx, then that must give us y, okay, because we're going the other way. Well, y is equal to the arc cosine of x on A. So it equals the arc cosine of x over A, remembering that we also need to do that plus c. And so the question asks us to do that. It asks us to show that that this is true, okay? And we could show that that was true because by finding that the derivative of this actually came out to be equal to this, then going back, the integral must go back to that part. Okay, don't forget the plus c. That's the process that you need to show for question 1. Similar idea for question 2. And then when you go into further questions, it's just applying the rules. So the rules effectively that you're going to need, I'm just going to copy them in here just so we can put them on the screen. Okay, there. So these ones allow us to get more functions because we've got an A in this space and an A and an A in that space. So they could be different numbered values. Okay, there are examples from example 6 on page 200 that you can use to have a look at how you can apply some of those. A lot of the questions are just using those rules. Okay, so we need to be able to work on those. So that's what I want you to work on for today. Do your best. Any questions, send them through to Teams.